So let's take a look at how I integrated SQLite with my demo application. Keep in mind that you don't need to do anything special to use SQLite. It's already included in iOS. The SDK already has support in terms of APIs. However, it's a pure C API, and most people choose to use a library instead, either that's a wrapper around the pure C API in either Objective-C or Swift. I have chosen to use FMDB, which is an open source library, and as is the case with the other dependencies of the application, if we look at the pod file, the CocoaPods pod file, I have a reference to FMDB 2.5, and when you run pod install, it will resolve that dependency. Go get the code, build it, and include it in the application. In the rare event that you haven't already seen this 100 times, this demo application displays champion data from the League of Legends developer API. All of this data is retrieved by the application and stored in a SQLite database. And here you can see the champion images, which is the URL, the champion name, and all of this data is stored in the SQLite database. And we're going to take a look at the code that makes all this happen. I want to start by saying that all the database code in this application is modeled after the database support that's built into the native Android SDK. I really like the patterns that they use there, and I've simply made an iOS Objective-C port of much of that code. Let's start with a class in the application that is used to create and manage the structure of the database tables. This occurs when the application starts up. And I'm going to start with the base class in the core app module, and I'm going to look at something called the SQLite Open Helper. I'm not a particular fan of the name of this class, but this is similar to the class name used in Android, and I wanted to be able to make it obvious to those that have used that what this does. So what this class does is has the capability of answering a database, which is an FM database. That's an FMDB wrapper around the C API for creating a database. So all we do here, this class takes a database name and a version. And it simply opens the database when it's asked for. The first time you ask for it, it uses this constructor, this initializer, to create a database with a path that is inside of the documents folder of the application. And then it takes the version and uses the pragma command to set the database version. It does some other stuff in here which is beyond the scope of this, but you're welcome to look through this code and see what it does. Let's then look at the Data Dragon database support and look at the SQLite Open Helper for Data Dragon, and that is a subclass of the base class that I just showed you. So it accepts the database name and version, but look what happens here. I have an inherited method here called onCreate, and this gets called by the superclass when the database does not exist and it must be created. So you'll notice here that I have methods to create the realm table, the champion table, and the skin table, and each of those methods gets called individually. Now it looks a little bit weird here because I use string formats to plug in data to construct the actual command. So let's start with the realm table, and it simply does a create table, and it creates using all of this bindable data. So the table name, the column name for the realm version, the CDN, etc. All this gets bound in to make a SQL string. And then the database has a method on it called execute update, which allows me to execute any create or drop or insert, update, or delete. And I simply pass that string along to create the table. The same occurs for the champion table and for the skin table. So I simply use this SQLite Open Helper to create the database when necessary. I also have upgrade and downgrade capabilities as well as reset. And if the database needs to be reset for any reason, I first drop the tables, the realm table, the champion table, and the skin table, and then I will recreate them. So that's what happens here. Reset and then recreate. And those will create empty tables for the realm, champion, and skin. So to summarize what happens here, the Data Dragon SQLite Open Helper is the class that is responsible for creating the database and creating all of the tables in the database. It inherits from a base class which has the ability to determine the version of the database being used, comparing it to the version of the database that's on your device, and if there's a difference, it will either upgrade or downgrade and allow you to write logic to alter the structure of your database when either of those two occur. So I would encourage you to look at the NIO Data Dragon SQLite Open Helper and its superclass, or the base class for all SQLite Open Helpers, the NIO SQLite Open Helper. Pay particular attention to the methods that I declare in the class. These are essentially lifecycle methods that will get called automatically by this class, and the subclasses of this will override to implement logic that occurs at the various lifecycle events. So for example, on configure, on create, on open, on upgrade, and on downgrade. And your subclass can run custom logic on any of these events.